Welcome to Summarize Science, where we break down complex research into simple terms. We all know large language models can be slow, generating text one word at a time in a long, sequential process. But what if an AI could write entire sentences or paragraphs all at once in parallel? A newer class of models called Masked Diffusion Models, or MDMs, can do just that, sampling words out of order. The big question, however, has always been how to do this efficiently without sacrificing the quality of the text. This is where the unmasking schedule comes in. It's the strategy the model uses to decide how many words to generate in each step. In this groundbreaking paper, researchers provide a new, exact characterization for the optimal schedule for any given set of data. They discovered an elegant connection between this AI problem and a classic math concept called univariate function approximation. Essentially, every dataset has a unique information curve that describes how much its words depend on each other. The researchers showed that the total error in the generated text is equal to the area between this information curve and a step function approximation of it. This means the best schedule is simply the one that creates a step function that best fits the curve, minimizing that error area. But there's a catch. Finding this perfect schedule requires knowing that information curve ahead of time, which is practically impossible for most real-world data. The paper proves that without this, a priori knowledge, you can't just query the model a few times to figure out the best schedule on the fly. Just when it seems hopeless, the paper offers a practical and powerful solution. They demonstrate new sampling schedules that don't need the entire complex curve to work well. Instead, these highly effective schedules rely on just two well-studied, high-level properties of the data, called total correlation and dual total correlation. Think of it like this. Instead of needing a detailed map of a mountain range, you just need to know its highest peak and its total area to plan a good route. This reduces the problem from designing a schedule with potentially thousands of different parameters to one that depends on just two main numbers. In practice, this means developers can simply experiment with these two values to find a schedule that works incredibly well. So, what's the big takeaway from all this? The researchers have provided a complete theoretical understanding of how to schedule parallel text generation in diffusion models. First, they define the perfect, optimal schedule using a beautiful mathematical connection. Then, they showed the practical limitations of achieving this perfection, but immediately provided an alternative, near-optimal strategy that is easy to implement. This work shows that in many natural settings, you can generate a sequence of n words in a tiny number of steps on the order of the logarithm of n, with no visible loss in quality. This research could pave the way for a new generation of language models that are not only powerful, but also incredibly fast and efficient, making advanced AI more accessible to everyone. Thanks for watching Summarize Science.